Good morning. My name is Shane Mass. I work with the IVEK Technical Service Department. In this situation, we have a 23 frame motor base with the gland recirculation option. So what that is a recirculation groove in the back of the ceramic set for keeping the ceramic piston wetted. So here we have the Digispense 3009. It is a multi-voltage system, 120 to 140 volt. This is where we plug in our motor cable. This is a Logic I/O adapter, RS232. I have a contact trigger, so a simple shorting of, say, a foot switch or a push button switch will activate a production mode trigger, and an auxiliary output as well. In this situation, connected to that is our 23 frame motor base. It is a AP motor base with the ability to fully open for what we call auto prime. It's a 3A piston cylinder set, and here we have our input, and we also have the gland recirculation input. Input to the left, output to the right. We would refer to this as the motor. This would be the displacement head, and this the pump. Displacement is adjusted by turning the screw and locking into place. With the 3009 or any of our systems, included is an extension cable. This would be referred to as the motor cable. One side will be metallic, the other side plastic, also known as an amphenol connector or amp connector. Your CPC, circular plastic connector, is going to plug into the motor base itself. Any connections, as shown here with the yellow tag, must be done with the power off. If you turn the connection, you'll find that there's a key at the top of both. You can turn them until you find the locking connection, twist in and turn. The same goes for the 3009. There's a top key pin and a keyway on the back of the controller as well. Plug in, turn. Connection complete. And apply controller power. The gland recirculation module, very basic operation. Its job is to move fluid. Forward, reverse, indicator lamp for power, input, and output. On the back, we have a heat sink and a power connection. Rated voltage is stated here, and these systems come in 115 or 120 volt and 220/240. They must be ordered as such. They are not power conversion. And on the bottom will be the serial number for reference. Next, I'd like to cover tubing connections and the different types of ferrules and nuts, locking ring. Tools that may be required. Tubing cutter. I find this very important for the simple fact that the tubing requires a very flush, straight cut. If there's any angles to the cut, it can generate air or a leak and make quite a mess in the ceramic set, or worse, affect dispensing accuracy. Another tool is what we call an extension tool for tightening the ferrule nuts. So here we have a nut, a flangeless nut. It'll simply go on like so, and you tighten into your pump. And it has a groove cut in it for the tubing. We also have one for what we call a headless nut. So as you can see, this would be more something for a gland or a very small pump, whereas this has a larger shoulder on it. This is for the headless nuts. This headless extension tool is IVEK part number 142590. And this extension tool is IVEK part number 142220. And our smaller tubing cutter, which covers 1/8 inch OD and lower, is 052238-01. This information can also be found on our website. Now I'd like to cover the basic connections that you can find in this setup for tubing. So what we have here is a ferrule nut. And I don't know if you can see that, maybe tough to see, is a ferrule. This is called a flangeless connection. In the flangeless connection, you insert your nut and then the ferrule itself. This is where it is critical that the tubing is cut flush. You can open your tubing cutters, feed the tubing through, and have a nice clean cut.
Calling out, please dial 136, call 136.
Push the tubing back so it's flush with the ferrule. Install into the pump. And I choose to tighten with the extension tool. That gives me a better torque value instead of turning too hard or too loose by hand. When you hear the click, you're good to go. Advantage to the flangeless setup is it's one and done. It's a ferrule and a nut. You install it, job complete. Disadvantage is these two items can stick together and they're not reusable. So quite often when you try to reuse them, you'll have your tubing turning and being stuck. The advantage is they're much cheaper. Perfect example. So this I'm going to make the output, which is FEP tubing 16th inch OD by 30 thousandths ID. Another option is called super flangeless. So we have the same setup here, except for this ferrule nut has a recess in it. And now we also utilize a ferrule, just like the flangeless, except for there is also a stainless steel locking ring. Anytime you see these stainless steel locking rings, one side has a flat and one side will have a recess or a taper. The flat always goes to the ferrule. So in this case, we install the ferrule nut. I'm going to flush cut my tubing. Now the flat side of the stainless steel locking ring will go down into the ferrule nut, and then the ferrule itself will get installed with the taper going down. If they slide on very easily, that's a good sign. Now what I'm doing here is I'm not making a loop for a fluid path, but I'm using the pump to crush the ferrule onto the tubing. Super flangeless connection complete. Now you'll notice I can pull the nut away and the connection remains. And it's nice and flush. If it protrudes, you will need to cut it. It is not recommended to let that happen, but in the event it does, very carefully cut it. So advantage to the super flangeless is ability to reuse. Disadvantage, more parts, longer assembly time, and increased cost. I do, however, choose this connection. Moving on is a headless nut. In this case, I have a flangeless one, not a super flangeless. Installation follows as with all other ferrule and ferrule nut connections. Slide the ferrule nut over the tubing. Ferrule follows with the tapered side down. And install. This can get tricky, and this is a great time to use the extension tool. Now you'll notice the tubing is stationary with the ferrule and the nut. That is a good flangeless connection, but not very easy to disassemble and reassemble. Another great option with the 1/8 inch tubing is a one-piece peak ferrule. This ferrule, you'll notice, in comparison to others, actually has the locking ring pre-assembled, and it is free floating. Simply install this onto your tubing. I choose to push it down so it's flush. Install. And tighten. This is a great alternative to the super flangeless. You cannot remove the nut, but everything is tight here. You can slide it back and make your cut. If you try to reuse that piece of the tubing, it's been crushed and your connection will be compromised. In closing, with our 1/8 inch tubing, we have a headless nut that is required to be used in a gland application because we have the gland port and closely followed by the fluid port for dispensing. This is a flangeless setup, so it requires a ferrule nut and a ferrule attached to the tubing. Another option is the one-piece peak ferrule and locking ring attached. It is one piece, but it allows you to turn without sacrificing the tubing being stuck as well. Then we have the super flangeless, where we have the ferrule nut, the ferrule, and the stainless steel lock ring. Here we also have a super flangeless headless nut. This is going to work just like any other super flangeless tubing setup, where it has a recess, the flat goes into the bottom, and then the ferrule would go as well. Now let's proceed with a basic setup of the dispensing system, including the recirculation module. The first thing to set up, I choose, is the gland. You're working with smaller ferrule nuts, and the direction of fluid flow is critical to proper operation. With a gland, you don't want to generate pressure into the pump head, because it could essentially push fluid past the clearance and into your dispensing fluid. So you actually want to draw the fluid. So first of all, I'm going to use a 1/8 inch tubing with a headless ferrule nut. And this is going to be the beginning of my fluid path for the gland. My fluid is going to be drawn from the reservoir into the pump. Now I need to make the output of this side of the gland port go to the input of the gland pump. So I'm going to be drawing fluid from the reservoir through the gland. So I'm generating a negative pressure, if you will. I'm pulling vacuum. Install my ferrule nut and my flangeless ferrule. Install that. And now the output of your gland, you can either return it to your gland reservoir and the fluid will be reused, and then I highly recommend it be changed every certain amount of dispenses or time based on your application. Or if you're running something like deionized water or just basic water, you may choose to waste what comes out of the gland. So my output will go back into my reservoir in this case. The gland circuit is complete. So with forward motion, I'm going to draw fluid from here, which if we follow back will be the output of the dispense head, and it will be drawn from the reservoir. As you can see, fluid is coming up through, passing through the gland circuit, it's being drawn. Gland circuit is complete. A common rule is, I use this for priming, if you will, so it's traveling very fast, but just a drip or two every couple of seconds is all you need. Now that the gland circuit is complete, the fluid path of the dispensing system is quite simple. It's a matter of an input and an output. A general rule is we want to be able to flood the input. So in this case, we're going to use 1/8 inch tubing, OD, 16th ID. I have a superflangeless connection here, and this is going to be the input. Now, for this application, I'm choosing a lure adapter with 1/4-28 threads. Install and tighten. And this allows me to use a variety of different nozzles. Now, this shows a good example of why I would choose superflangeless. I'm having trouble turning the tubing where I need. Whereas if I had superflangeless installed here, I would be able to articulate the setup much easier. So now, I'm going to power on the Digispense 3009. And the system's requiring a reference. Page 76 of the 3000 series manual allows you to choose the proper motor base, which you have. In this case, I have a 23 frame Microspense AP, single end. So my choice is going to be motor number 2. Having the wrong motor selected can cause your system to fault or inaccurately dispense. So I'm going to go to the far left button to the prime screen, and then the second button in, setup A, setup B, and setup C. In setup C, my first selection is motor base. I'm going to go down, and I'm going to change that motor base number to 2. Now I have the proper setup. This is also where you can change your stop position if needed. It comes from the factory at 90. And you can also change your acceleration and torque. Your acceleration can be critical for cutting off your dispense profile properly. The options are slow, medium, fast, and fire off. I'm going to stick with the factory medium here. And now I'm just simply changing my prime rate. You can see the fluid coming up through. Filling the chamber. It may be tough to see, but it is coming out. In this short length of tubing, I'm now primed. So I'm going to do a dispense of 1 stroke at 100 RPM. Now to 500, and we'll see a critical change. I'm essentially shooting the fluid. So as you can tell, with any application, there's a lot of setup required to get that proper dispense profile that you're looking for. That is a basic setup of setting up the Digispense 3009 with a gland recirculation module. So in closing, we have many different ferrule types to connect with. I prefer the superflangelless personally for ease of reuse and the ability to articulate the tubing as needed without kinking the tubing. Headless ferrules required for the gland circuit. As you can see, it's a very tight connection here. So we have the input of the gland circuit on the back left side. Then we have the output going to the input of the gland. So we're drawing the fluid from the reservoir and returning it to either waste or back into the reservoir. On the dispensing side, we have our reservoir flowing into the input, and then our output, generally a smaller size tubing, or at least equal size, connecting to some type of nozzle designated for our application. If you have any questions, you can email IVEK via the website or contact IVEK Technical Support.